You have 1 Bitcoin, which you have invested in the Bank of Adam for some period of time, after which I pay you another Bitcoin back in interest. It's rent for you letting me use your crypto for that amount of time. Let's just call it a year because it's crypto and it's full of surprises. So here's t equals 0, and here's t equals the doubling time, which we'll call 1 year. At t equals 0, your investment is worth 1 Bitcoin. Is that what it looks like? I don't know. After a year, it's 100% interest. You now have 2 Bitcoins. Is that where you put the B? I don't know. Okay. So your investment is worth 1 Bitcoin until suddenly, all at once, I pay you the 1 Bitcoin interest. That is simple interest. Compound interest. Halfway through the year, what if I pay you that half Bitcoin? So now you have 1.5 Bitcoin, which you then reinvest. You're going to get the interest on the original Bitcoin plus interest on the half Bitcoin, and you'll end up with 2.25 Bitcoin. That's your 1.5 Bitcoin compounded twice. What if we compound it more frequently? What are you going to end up with at the end of this 1 year? Let's bring it to Desmos and crank it up. You may recognize this as the familiar constant of constant growth. Interest compounding constantly gives you a return of E, 2.718-ish. Let's expand this using the binomial theorem. A plus B all to the power of n equals this. I'll link to a refresher at the end of the video. A is 1 and B is 1 over n. So we've got over 0 factorial, we have 1 to the power of n plus n times 1 to the n minus 1 times 1 over n to the 1 over 1 factorial, then n times n minus 1 times 1 to the n minus 2 times 1 over n, all to the second power over 2 factorial plus and so forth. This 1 is not going to have an effect on anything because 1 to any power is just 1. So let's rewrite that as 1 over 0 factorial plus, we've got n times 1 over n. Well, that's just 1 over 1 factorial plus, here we've got n squared minus n times 1 over n squared all over 2 factorial. When n is very large, this n will become insignificant, which means these two again will cancel out. And the same goes for the next term. N times n minus 1 times n minus 2 all times 1 over n cubed. These 3 n's will matter. These small amounts will disappear, which means everything in the numerator cancels out, and we end up with just the sums of the reciprocals of the non-negative integers factorial. We can make this as close to E as we like by choosing a sufficiently large n, just like we did over here when we cranked up n into the tens of thousands. What if we want not just E, but e to some power x? we'll just multiply this exponent by x. In our binomial theorem, wherever we had n up here in the numerator, now we have nx. Not so with the 1 over n. So the n's, as before, are going to cancel out for large N. These become irrelevant, these small numbers, and we end up with 1 over 0 factorial plus x over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the n over n factorial. Differentiate this function and you will find that you end up with the same function. Now, as our final hurrah, let's talk about the inverse of this y equals e to the x function, which would be x equals e to the y function. Solve for y and we get y equals some function of x. This first function answers the question, what do we get when we raise e to some value x? This function answers the question, what do we need to raise e to get x? And we have a name for that. It's the logarithm of x. It's a function which we can define. It's not ln x. Let's find the derivative of this new function. Let's take the derivative d by dy of x on both sides. We'll just keep this side as dx by dy, and this side ends up being unchanged. Fair enough. Okay, but we want dy by dx, so let's just take the reciprocal. dy by dx is 1 over e to the y, but what was e to the y? Well, we said it over here. We defined it as x. So dy by dx is 1 over x. That's the derivative of this log function. Bob's your uncle. Here's the whole calculus playlist plus the binomial theorem refresher. Subscribe to be notified as we add new items to the playlist. And cheers.